Hi students, our study today about complex number. We're going to start by video 1. We're going to define complex number. Complex number is a number written of the form z equal a plus ib, where a and b are real and I is a square root minus 1. Square root minus 1 we all know does not exist in the real. It's impossible. However, we have created a new set. This new set called complex number denoted by this C, where square root of minus 1 exists. So that's why, for example, if you go here to this example to understand, if you have square root minus 7, a real does not exist. So that's why I said in the set of complex number, I want to tell you where to work. If I say in complex number, so this is possible. So square root minus 7 is square root minus 1 times 7. You can split it. And since I is root minus 1, it will be I square root 7. If you have 2 minus root minus 5, same story, you can write it as 2 minus square root minus 1 times 5. Square root minus 1 here is I, 2 minus I root 5. And the last one, it will be square root minus 1 times square root 36, which is 6i, because square root minus 1, as we said, is I. Any complex number has a real part, this is the real part, and the imaginary part. The imaginary part is the coefficient of I. So here in the first example, we don't have a real part, but we have imaginary, which is radical 7. Here, the real part of the complex is 2, and the imaginary part is minus radical 5. Here in this example, that one, the real part is 2, and the imaginary part is 6. Always, the real part and the imaginary part are both real numbers. Real numbers, okay? A complex number is said real when we don't have I, and b is 0. If b is 0, you have a real number, z equal to a, where a is a real number. A complex number is said imaginary or pure imaginary when we don't have a. We have only ib, 3i, z equal to 3i. This is called pure imaginary. Z equal to 2 is a real number. Z equal minus 3i is a complex number, but it's called imaginary, pure imaginary. Why? We don't have a plus a number. Hala, write the complex number in the term of z equal a plus ib. You have x squared equal minus 6. This is impossible in the real, however, exists in complex number. So if you remove the square, you all know, you put plus or minus square root minus 6. And this is possible since we're talking in complex number. Root minus 6, we all know, as we said before, it's I root 6. So you have two parts, plus or minus I root 6. This is pure imaginary. Why? Because I don't have a. Like this example number 4, I have a. So here, pure imaginary. So here, if I take x squared equal minus 16, it's impossible in R, but exists in C. So if I remove the square, I put plus or minus root minus 16. And root 16 is 4, as you all know. And root minus 1 is I. So I have plus or minus 4i. So here, it's also a pure imaginary. If you have x equal radical minus 8, radical 8 into I, because radical minus 1 is I. So 2i radical 2. Also, this is pure imaginary number. However, if you have z equal minus radical minus 6, this can be written as we said 7 minus I root 6. This is the real part, and this is the imaginary part, which is minus radical 6. And here, this will be 2 minus 5i. The real part is 2, and the imaginary part of this number is minus 5, as you can see. Now, we said I is root minus 1. If you want to find its square, so minus 1 all square, it will be minus 1. Hala, I cube is I squared times I. So minus 1 times I is minus I. If you want to do I power 4, so it's I cube or I square square. Minus 1 all square is 1. So I is I square is minus 1, I cube is minus I4 is 1. If you want to do I power 5, it will be I4 times I1. But I4 is what? Here we said 1. 1 times I is I, because I4 is 1. If you want to do I6, so it's I5 times I times I is I squared, so which is minus 1. If you want to find I7, so it's I6 times I, and minus 1 times I minus I. I8, it's I7 times I, so it's minus I times I minus I squared. But I squared is what? Minus 1. So minus times minus 1 is plus 1, and so on. So you need to know, if you have any number, for example, I13, we have 4 classes. It's either I, or minus 1, or minus I, or 1. So you take the number, you divide it by 4. 13 divided by 4, what is the rest? 1, so it's I power 1. 14 divided by 4, what is the rest? 2, so I square is minus 1. 15 divided by 4, the rest is a 3, so it's like I3 minus I. 16 divided by 4, no rest, so I0 is 1. So that's why I power 4n plus 1, if remainder is 1, when you divide by 4, it's 1, I is I. If remainder is 2, it's minus 1, I square. If remainder is a 3, I cube is minus I. If no remainder is 1. For example, if you have I power 29, 29 divided by 4 remains 1, so it's 1. 18 divided by 4 remains what? 2, so it's I square minus 1. 43 divided by 4, remainder is a 3, so it's I cube, and I cube is what? Minus I. 20 divided by 4, no remainder, so I power 0, minus 1. Here, if you want to simplify, 2 power I11 minus 7 I16. If you divide 11 by 4, remainder is 3. If you divide 16 by 4, remainder is 0. I cube is minus I times 2 minus 2I. I0 is 1, so minus 7. Here, if you want to have square, I square is minus 1 times minus 3, it's a 3. I11, if you divide it by 4, remainder is 3. 8 plus 3. So it's I cube, and I cube is minus 2, minus I. Minus I times minus 2 is 2I. So now we have A plus B squared. So it's A squared plus 2AB, 2 times 3 times 2I, plus B squared. B squared yani 4I squared. 4I squared is minus 4. So 9 minus 4 is 5, and plus 12I. This is the real part, and this is the imaginary part. Now simplify and write in complex number. We already know 2 minus radical minus 5, it's directly 2 minus I radical 5. Radical minus 2 times radical minus 3, you cannot multiply because you need to input I. So this is I root 2 times I root 3. I times I square. But I square is minus 1. So minus root 6. Here you cannot multiply, you need to include I first. So it's 2I root 5. This is times I root 3 plus root 5. If you multiply 2I square root 15, here root 5 times root 5 is 5 times 2 is 10I. I square is minus 1, so minus 2 root 15 plus 10I. This is the imaginary part 10, and this is the real part. The real part without I, imaginary with I, coefficient. Here the same story, 2 minus I root 5, 2 plus I root 3 plus 2, I expand, 4I root 3 plus 4, minus 2I square here, minus 2I square here root 15, I wrote root 10, suppose this is root 15, and minus 2I root 5, so the answer will be 4I root 3 plus 4, I square is minus 1, it will be plus 2 root 15, here 2 root 15, minus 2I root 5, so I put the real part together. I have 4 plus 2 root 15, here 4 plus 2 root 15, plus I factor 4 root 3 minus 2 root 5. This is the real part, 4 plus 2 root 15, and the imaginary 4 root 3 minus 2 root 5. Here the same story, you expand A square minus 2AB. B square, it means 5I square, but 5I square is minus 5. 4 minus 5 is minus 1. This is the real part, and this is the imaginary part. The last part in this video, two complex numbers are equal when real equal real and imaginary equal imaginary. So if you want to find m and n so that these two complex numbers are equal, I start with the real part, the things without I. Here I have 2m, here I have 2, so 2m plus 2 equal to the real part in the second part, which is a 3. Imaginary, where coefficient of I here minus 3, and here 2n minus 4. So you solve for m, you're going to get half, and n equal half. The last one, you expand 6i minus 2m minus 14in. Here for 28i square, which is minus 28. Similarly, equal minus 7i. The real part minus 2m minus 28. Here I don't have real, I put 0. Equal 0 because plus 0. The imaginary part is minus 14n minus 14n, yes, plus 6 here, equal minus 7. So m will be minus 14 and n will be 13 over 14. Thank you for listening.